have a machine that more closely resembles the Commodore 64. You really just greet it with a start with a typical basic prompt, and you will get then have the ability to via a menu button to then insert disk images and stuff like this. So it feels more like an emulator and not like a gaming system. Yeah, and I was just thinking about if there are questions, also throw them in. And also one thing about this is the VICE is, the emulation is based on VICE 3.3 for the BMC64, so it's much newer, it's much more compatible to, or runs more things correctly. And you also have then the opportunity to run not only the C64, the base model of this C64 is also contains some VIC-20 games, so it also includes VIC-20 emulation. But the BMC64 also has, as we can take a look at the webpage, so we've got a 128 mode, VIC-20 plus 4, even twice, because the original emulation of the VICE isn't that perfect, and you can even run a PET. Running the PET within this case is complicated, because of the major differences within the keyboard. If you want to run it with I have to take a look, with a +4, which also has a different keyboard, then there is some nice thing. Let me just take a look at the page, I think. Yeah. There was a project by Michael Style who did a patch for the C16 so that you can use the layout of the original keyboard without, like you're used to with a C64, so that you can use a C16 with the same keystrokes as the C64. So you have then to tape over your keys on the C16, or when using this kernel with the correct configuration of the C16, then you are also able to use the C64 keyboard like you would expect it. The only missing key is the restore function, since this key is not supported, or the NMI that's been executed when pressing the key on the C16 is just not available. So what I've mapped in there is the escape key, which is really the only key on the C16 keyboard, which is not available on a C64 keyboard. So I also handed in then some patches for Randy Rossi to have this one working in there as well when you're using the matching kernel for this. So this would be now the time when I start assembling the machine. Since we are still waiting for our camera child, I was hoping that it might drop in, then I guess to give him at least some 4 or 5 minutes to show up. Are there any questions? Oh, come on, I can't be that good in explaining. Yeah. So the question was if there is support for real hardware cartridges. Since it's running an emulator, there's no chance. There's no chance. Technically, it isn't just possible. If you really want to have support for a real cartridge, you have to go for an FPGA emulate or recreation of the system. This is an emulation, and this is the only way that you have got the chance there. But still, since it's VICE, almost all the cartridges that I can think of are emulated there. Okay. Okay, with MIDI you've got no chance there. So I think somehow support would be possible with MIDI, but then you can't do it with a Raspberry Pi, at least not without the Linux implementation. I guess with Linux there is a configure switch which you can use to have then MIDI support somewhere in there. But this is something I suggest you come up to me after that, and I will take a look at the whole configuration stuff of Vice and see if it could be compiled in a way that you could use MIDI. So, another question.
Yes, I have a question. We are just developing a demo on a normal PC, and then I want to try it on this machine. How to interchange like the new version without changing the SD card. Is there a way to transfer files?
No.
No.
No. This really is thought as a recreation where you have a standalone machine. So the SD card is the only thing. And also, since you want to have, if you're developing on a PC and you don't need this machine to transfer it on, you can run it in Vice within your development machine, the emulation will be the same. So it doesn't really, you don't get an advantage for this.
If you want to have 50 Hertz on a proper monitor and you don't have this on the development.
Okay. Okay. That's a good point. So you bring up something which I then also can put in advance in there. What I also did is, as you stated with 50 Hertz, I built myself also an SX64 machine. So what I did there is I bought some case that you can use to build in your own digital equipment. And I then designed some 3D printed stuff, bought a display, and I was really glad when the machine was fully built and I tried it the first time on. It was really like I imagined it. Then I ran some demos and I began to wonder. Something wasn't a bit off. And rather soon I discovered that something was the sound. The effects that were accompanied by a sound, where the sound came way too late. So I tried, the 8-bit guy did a nice demo for testing this. So it's just a CRT that you can load in, and when you press a key or a joystick button, something like this, it then toggles the screen color and plays a sound. And these two effects should be at the same time. With this installation, it was something 1.5 seconds later, the sound, than the display change. So, and I was really racking my brain, what could have been going wrong? What is this thing? The machine does not use, or the display does not use the HDMI port for video output, but it uses the DPI, so the onboard connector for displays. And I guess somehow this display isn't really compatible with 50 Hertz, or at least in a way that the emulation gets so out of bound that this huge delay for the sound then occurs. So, and I have done with this key mapping stuff and so I have done some development on this code, and the code is not really fun to work on. So if you want to build a system, you have to go some devious build instruction, have to run 2 separate builds, and one is for the Vice part, and then you take the libraries created there and implement them in the configuration for the stuff. And also you have to have a rather strict environment, so something like a Docker image also would be a nice thing to go for, so that you have exactly the right compiler. So this is why, at the point why I stated, I don't want to debug this, and I just think it looks nice. I put it on a shelf, and if I want to do something, I take this machine, or later something like an FPGA emulated C64, or a real machine my or C28 AD that I've got at home. There was another question.
I think I figured it out, but there will be a question anyway. Sorry.
Yeah.
On one side, the C64 is just a full and complete solution,
Yeah.
hardware and software. And the BMC64 is basically just the software. You have to take care of getting all the hardware by yourself.
Yes.
Okay.
So. Another question?
Yeah. So is there support for these two SD cards? So you can have the BMC64 on one of those cards and really have one other SD card as media for transcribing images.
Yeah. So the question I've also forgot to replace. Let me just repeat both questions because I'm not sure if they got on the recording. The one question was also the difference between this C64 that it is one solution that comes with software and hardware, while the BMC64 you only get the software and you have to take care of using the hardware yourself, or taking care of how to get the hardware yourself. Also, the answer to this is yes. Also, what you can do is just, if you've got an old Raspberry Pi lying around, you don't know what to use it for, you could also just use the bare machine without any additions and plug in a USB keyboard and use it like this. This is also possible. So, and it runs from Raspberry Pi 0 up to Raspberry Pi 3. The Raspberry Pi 4 family with the 400, the Compute Module 4, is not supported because the code is tightly coupled to the Video Core 4 video chip that's on the Raspberry Pi 0 to 3. And with the Raspberry Pi 4, they introduced the Video Core 6. And nobody has taken care of how to get the code running on the Video Core 6, which also means that you can't use the wonderful Raspberry Pi 400 keyboard computer like a C64 just with a bare metal. In this case, you have to go for a Linux operating system and run then Vice from there. So, and the other question was having additional storage. So, the one thing that you can do, as far as I know, I haven't really tested it out, as it wasn't really useful for me. Because let's just take a look at this Raspberry Pi 3A. That's built in there. What you could do is you could plug something into the USB port. And this could be an additional SD card reader or something like this. And as far as I know, so this is not just what I read and not what I tried myself. As far as I know, it does work, but when you change the media while running, then the detection won't work correctly. So if you need to exchange something, you have to turn the machine off and on again so that the media is correctly recognized. Please say that you are my camera kid. Okay. Okay, so there, but since turning on the machine takes something like 4 seconds until you get the emulator up and running, I think that's the downside is you lose your data, but from the time perspective, it's okay. Pardon? Yeah. But this is something, as far as I know, is that is implied by the Circle, which is the bare metal operating system, I would like to call it. So it has to be implemented in there, and then you have to use the new environment to get this one in as well. And as I stated, compiling your own code for development isn't that easy. So, any other questions? Okay. Then I guess we should switch the picture from from the notebook now to the camera so that I can see a bit what everybody else is seeing when I put together the machine.
Right now that's not possible, so you need to hold it up. Hold it up, yes. So I hope everybody doesn't flash or get closer.
Oh. How should I screw something in while holding up the machine? You really can tell that it is just the first morning of the whole thing. So I took off the lid. Okay, so what we need to screw in is the additional PCB. This is what I will start with. So what I also did is I 3D printed some parts so that we have something like a nice cover for the power socket. Since it was very hard, or since I didn't have any filament matching the color even remotely, the best thing that I had was white, and that looked awful. So I printed everything again using transparent so that the original color shines a bit through and it doesn't look that awful anymore. So let's just put it together. So also, the typical mistake that I make when I'm putting this together is that I go for the top screw for the first, of course, because there's the lid that you're gonna print, the cover that's gonna print it, and then I go top down from top to bottom, and this is a bad idea because this one also needs to have screwed in the bracket for the keyboard. So that's the mistake that I always do, and today is the first time that I really think of it in advance and go with the bottom screw as the second one. So with the bracket screwed in, everything, so we've got at least one holder for the keyboard and also the machine itself. Also, there were some design. Okay, I have to take the machine. When I saw the design that Randy Rossi did for the PCB, there were two things that I thought that might have been different. The one that's really worth talking about is you see that we've got in here a USB connector, which is for transferring the power from the machine to the Raspberry Pi. And I noticed, wait a minute, we've got also power transfer. We could do it over the 40-pin IDE cable, so the GPIOs. And so I did a small patch. Let's just scroll to the right. Which looks like this. I just took well, let's use the mouse cursor. I just took the power rails and had them down to the 2 power rails that were available for 5 volts on the GPIOs. And there were 2 ground leads that I shorted just using the wire from the lead that goes to the ground pin there. So this is, if you want to save on the USB wire, then you can just use this small modification that's in there. This is also included in this board that I've got in there. I forgot to show it, and now I want to unscrew it again. So, then let's start with the other thing that's rather easy, which is the other bracket. I heard some mumbling, so maybe another question for me to answer? Not so lucky. So, hey, I think the best thing would be if you can take the camera just in the hand and just hold it really down on while I'm doing this. Okay. Nevertheless, I will continue. So, then we get to the more interesting part. The bracket that I designed is also an exaggeration. I took an original design that was done for Raspberry Pi 3B, and I modified it so it would match the 3A together with the SD card extension cable. So, and for mounting the SD card extension cable, I had the idea of using these zip ties. So let's just put that one together. And also, let's just take a look. Also, I could also give a word about the as you can see with the insides of this machine, this cable is the variant that's been sold as 15 centimeters. And as you can see, it's a really tight fit. And this one only works if you put in the reader in a way that it's that you have to put in the SD card upside down. Since you could claim it is not untypical when you're working with a Raspberry Pi. The first time you take this machine out of the shelf and want to do something with it and try it, I always put it, take the SD card out, put it in my SD card reader on the PC, put some stuff on it, put it back in the machine the wrong way every time. So I've gone this time for a lead that's slightly longer, so that's 50 centimeters, because I couldn't get the perfect size, which would have been 25. But that was not available at the time I bought this. But still, for the right fit, let's take the SD card. Mumbling, question? No. Hey, it worked first time, so okay, with the logo, it's the upper side. So now let's get to the and as far as I can tell, with this kind of extension cable, there is only this version. So everything you should just buy, if it looks similar to this, it should fit just fine with my 3D print design. So now let's just get the whole zip tie stuff done. Yeah, let's just go for this. Fuck. The only thing that I didn't test so far. Let's go for Saga. So we need to do take off a bit of the extra 3D printed stuff, so that hopefully then it will fit. Still not fitting. Okay, let's just, it should just work. Let's just try it. Also, I noticed that the design, if you come up with it, it is printed in the height that's flush with the rest of the machine, with the rest of the case. So either you have rather, you need something like a washer to put underneath it, so that you have really a good hole for the screw. What I did, I got lazy, I just 3D printed my own washers that would fit.
Question.
Yes.
On the other side of the printed part, does the zip wire go?
Yes, there. Yes, there's a little channel.
Okay, yeah.
So, and what I did was a design that looks a bit like 2 holes for screws and a small channel below it. And with this time, the 3D printing, the holes for the screws were a bit too tight for a fit, so that the zip tie doesn't fit 100% without taking off some filament there. So this is what I will also go for once I've completed, to make it really nice. Yeah, then we need to take in the Raspberry Pi 3A, which is, by chance, the best thing that could have happened, that is based on this design. Because if we take a look at the currently available boards, almost everyone is a Raspberry Pi 3 Model A. So, and also for a price that's around between around 30 euros. So it's really be something that's rather cheap. When working with a Raspberry Pi 3, mounting it anywhere, there is one thing you have to be very sensible to, because it is sensible itself. This is the USB port. The USB port on the B machines is wired to a USB hub that also does the Ethernet part. So if you touch a USB port there, static electricity will only go to the hub, and this one is better capable of running, of handling some starters on this. If not run through the USB hub, then this port is directly connected to the CPU. And because of careless handling of the USB port of the Raspberry Pi 3A, 2 of the something like half a dozen boards that I had in my hands so far died. One was really just by static electricity. It was really a discharge, a small flash, and after that, the machine was dead. And the other one was a bit stranger. I was working rather well with this, but I used some USB devices, plugging in, plugging out, and for some reason it started also failing rather, But in both cases when the machine died, I was handling the USB, so this is also a cause why in this design I didn't put out the USB port, because it is so delicate. So, nevertheless, from the design perspective, it fits rather nicely in here. So with all four holes, it can be then just easily screwed in. Dum, 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 dum. The screwdriver is magnetic, the screws aren't. So then we just need to attach the SD card reader. Which in hindsight I should have rather done before this, but still it fits. And also with the IDE cable, I went for this time for buying my own cable and clamping on the things itself, because what I did is I put the connectors on in a slightly different way that it's typically done with IDE. With the typical IDE cable, both are gone facing the same way. I screwed them in that they are the opposite way because it better fits what we need here. As you can see, if we compare it with the other way that I did it, I needed to have a longer cable there so that I could twist it around in a way that's matching, and this is rather the easier way to do it. So, after this, the main thing that that remains to do is to connect the keyboard. And there also I like to make a common mistake. First screw in the keyboard and then try to connect the cable. As you can see, it goes way beyond. And so what I do is I first screw in the keyboard. Then I realize, no, it won't fit. So I screw it back off again. and then connect it the way that I'm doing it now. So still fucking annoying. Nope. I have, yes? As far as I can tell, he has no interest in emulating hardware. So he what? Yeah, that's a bit slightly. So you have to ask him for this. But what I can. Yeah, I don't. There isn't something available for this. What I can tell you is, since you asked, I wanted to put it in the end, but since you asked now. When I did this thing on the beginning of the pandemias, I was buying the PCBs. So I was going for the shortest or for the cheapest way to go them. That was a bunch of 10. Then the first lockdowns hit in, and the PCB manufacturer stated, "Oh, we are going to take some more time." And I said, "No problem. It's just a fun project. I'm in no time scale." And what they did as a nice gesture, they sent me not 10 but 20 PCBs that they manufactured. So when I then went off to buy all the things there that you required, so the sockets, the power switch, the connectors, the things, I was at this place. I looked up. So yeah. Everything gets cheaper when ordering a quantity starting with 20. So what I did back then was not realizing that it would take 3 years to get everything for a talk together. Yeah, let's just buy some stuff so that anyone who wants to can buy a kit to solder their own thing. So I've got a dozen of kits left. So I've used a couple myself, and then some friends thought, "Oh yeah, I want one. So there were some pre-sold, but I still have a dozen of Catlings, and you would do me a real favor if I don't have to take any one of those at home again. And I think the advantage that you have, everything will be sold for the pre-pandemic prices, for the pre-Chippergeddon prices. So everything together is something like 25 euros. And this also makes a rather good first project if you want to learn soldering. And I don't mean this as a selling argument, but really, if you want to start soldering, this is a nice project because there aren't any complicated parts in it. And the GPIOs are rather robust for short circuiting, except for very few. So with a typical problem that you might have creating a solder bridge, something wouldn't work, but you won't wreck your Raspberry Pi. So the GPIOs are much more robust than the USB port, at least for the A. So now let's put on the and the clip again. So let's put on the keyboard. So, and almost completed. We already have a new C64-like machine. and it has taken us, with me talking by myself, something like half an hour to build it. So it's really a nice project. You most probably will spend more time on soldering the board, of course, and also sourcing all the components. So going through all the web stores where you need stuff for something like the IDE cable or the Raspberry Pi, the SD card expander. And also what the board has, as you can see here, a connector for the power LED. And for this machine, I hope, this is also the one thing that I didn't test, if it really fits. Because the one thing that I tested it, but the one thing that I realized it, if it fits, you will never get it out again. At least not without wrecking the board, without that case. Yeah, I think I will let it at this point anyway. And also what I did for this machine is, since I didn't have anything else in this form factor, it's an RGB color, so you can select what you want to have for a color for this one. So this is ground. But if you need something else than red, then you most probably will you have to replace the resistor in there. So this is how you build the machine. The final part about this is the software. So we need to get, as you've seen, I've cracked open a new SD card from the case. And this is the only thing where I really did something, where I really contributed something to this kind of project, because what you have to do to set it up, you have to go to download either the zip archive with the files for the emulator, or you have to an image that you have then to flash onto the SD card. And reading something like Forum 64, there were always questions, yeah, how do I do this? Because, as stated, you have to add your own ROMs. So you have to download them from Vice and stuff like that. So, and also if you, for example, want to have the C16 ROMs with the C64 keyboard, you have to go for have to download all the stuff yourself. Like I stated, I want to have an action replay for use. You have to download this as well. If we maybe want to find a cartridge, you have to download this, and you all have to put it somewhere together, somewhat in one consistent file system. So let's just take a look what the SD card looks like if it has been mounted. Looks like it hasn't. Nope. There it is. So what I did, as you can, as a very short line at the end, there is a setup script. And here we have the setup script, and if you run it without arguments, then you get a short help message. It's asking for a destination directory, so that's the SD card. And we also want to have some GPIO configuration. And it is stated within the, let's just take a look. Oh, it has moved this one to another browser. Thank you. Wonderful Firefox. Let's take a look. README MD for the documentation. So if we take a look there, GPIO. Position. Yeah, there it is. So there we can see the configurations that we have. And can use a real Commodore GPIO config 2. This is the option that we want to use. So this is something that we also have to specify within the script. So we want to have the GPI configuration too. And now it just takes a look at the website. So it really detects what is the latest version. So if something like version 3.10 comes out, you can use this to update. It downloads the files, it downloads Vice, it downloads the ROMs from PokeFinder. So, and also puts them in a nice directory structure where everything is in there. Also an additional font, final cartridge. There it is. So we have our SD card set up. And now comes the interesting part. 2 questions. Yeah. The first of all is already no. The answer is no. The question was, is the lead long enough? No, it isn't. Nevertheless, somehow I can get it to work, hopefully. No, this doesn't look, yeah, okay, still. Backside. No, okay, I've got it. Where the problem is. I need to disassemble it again because I've had too much space in there. Yeah. Okay, plan B. Just to show that the SD card is working, before I start debugging this machine, I made the mistake of putting the lid a bit way toward outstanding, so this the power lead wouldn't fit in there. So I have to take it apart again. So and now I will just plug it in. Let's see what comes up. So now a question to the recording team. Do you have a problem with 50 Hertz HDMI signal? Or is nothing coming in and my SD card isn't working? I can also can go for a third option. Yeah, okay. If it doesn't work, I can. Since I have built so many machines, I just can take the SD card out there and put it inside my SX machine, so just can show that it's working. Of course, keyboard won't work now correctly because it's configured for the GPIO, or the typical USB keyboard would work, but just there it is. So. And yeah, something is definitely broken. So one assumption that I have why it's failing is that it's we are getting now towards sizes that are coming with problems for the fat file system to be used in embedded devices, at least. Stuff is there, but what I can still try is okay. Also, an advantage of the script is if you're gonna use it a second time, it won't download anything new or anything that isn't required. So you can just go. Let's take another look. Okay, time for more debugging. Maybe comparing it to an older card. So this is what it then should look like. This is the test case that I have with the audio delay. And from the other one, yeah, we've got my favorite action replay in there. So this is what's up so far. So Jürgen, can we get monitors capable of running 50 Hertz for the desk so that people can try it? He gives me a thumbs up. So I guess this then concludes the official part, except for one additional announcement that this machine, when built in a complete fashion, so that I really completed it, that it fully works and it tested, will be given to the Nordlicht organizers so that you can win it in one of the competitions. So yeah, I have enough machines, really, as you've seen. So I will have some fun then putting it back or together in a final form, also with slightly better cable management, and of course then in a working condition with SD cards, so that it's a turnkey solution with a power supply and everything else tested and working. So thank you for being up that early and listen to an old man mumbling about stuff he's done when he was bored. So, and we have until, I guess, something like 12:30, when Jens will start preparing his talk for 1300. So until then, I also brought a C64 with me, so if one wants to do comparisons side by side, what works on which machine, they will be here until 12:30, then I will start taking them down, and we will get the monitors, we'll get the power supply, everything we need to have it up and running. So if you want to toy around or even chat around, stay around, and we will then get things up now for you to toy with. So again, thank you for being here, also for coming back after 3 years to revision, and have an awesome party. Yes.